What are you talking about? So
We're going to be playing. State Michigan.
well, guess what? You'll still have to make homework after you go. So
Oh, true. I heard that if you win a state championship, you get parties. I agree. Yeah,
good luck. Good luck. I'm pretty sure she still got a bad grade in my class. So I might be the reason she didn't get academic honor diploma. So
Wow.
just saying.
Very mean.
I don't give grades. You earn them. So you know. I don't ever say, oh, based on who you are, or if I like you or don't like you, or if you did this athletic thing. I don't say, oh, let me just give you an A. I don't grade all these papers for my health. I grade them so you get a grade that you earn. So.
That kind of sounds like you're giving your kid 150 dollars or whatever. Talking homework.
What? Okay. Multiply. I think maybe did you have something like this on your homework yesterday, right?
Yeah.
Where you had to multiply stuff, didn't you?
Yeah.
We just did one. We did the square one.
That one.
We did do. So if I gave you something like this, and you FOIL it out, you should see something kind of cool happen. If you FOIL that out, 4 times 4 is 16, and the square root of 2 times the square root of 2 is the square root of 4. And if you want to go ahead and say times 2 there, I'm okay with that. I like to show extra work just so you have it to look at. And if I take 4 square root of 2 times negative 7, what am I going to get? Negative 28 square root of 2. You just multiply the numbers. There's nothing with the square root, so I just leave it there. And in the middle, if I take 7 times 4 square root of 2, I get positive 28 square root of 2. And 7 times negative 7 is negative 49. Right? The one that we did from the homework, we just kind of got a big ugly mess. But this one is kind of a cool one because what happens to my middle terms here? Yeah, they cancel out. One's positive 28 radical 2, one's negative 28 radical 2. This is actually a perfect square, so do you agree that's the same as 16 times 2, which is 32 minus 49 negative 17, which means we just took some pretty ugly stuff up here with radicals in it, and we got a lovely answer out of that, if negative 17 is lovely for you. Well, it's going to happen if you notice. You see that these are like the same thing, except for one's a plus and one's a minus? That's an important thing. That's a word in math. You know what that word's called? Starts with a C. Ends with the conjugate. I'm a good clue giver. Those are called conjugates. Because when you multiply a number times its conjugate, the square root goes away. We also use conjugates when we're trying to get rid of imaginary numbers. Because if you multiply an imaginary number by its conjugate, then it becomes a real number, like Pinocchio became a real boy. So a conjugate, if you have, I don't know, a plus the square root of b, then its conjugate is a minus the square root of b, right? It's the exact same thing, except for you change it to the opposite side. If it was minus to begin with, you change it to plus. Why is this important to us? Because we don't like to leave square roots in the bottom of our fractions, and conjugates help us to get rid of those square roots and move them to the top of the fraction. So that's the only thing with radicals that we didn't get you to yesterday that's going to be on your homework today. So let's just jump in there. This was on your homework last night? I don't think it was. Are you sure?
I'm pretty sure.
You just did it. No, yeah, there weren't any division ones. The only ones that were division were the one we did on the board with that you could simplify the fraction first. You only were supposed to go to 42 yesterday. I don't know, but it starts at 45.
Yeah, I went to 48.
There you go. You just kept on going. You did some nice homework. So first of all, a problem like this, you don't have to worry about a conjugate because you only have to worry about conjugates when there's addition and subtraction. If you see something like this, we just want to get rid of this square root in the bottom. What can I multiply the square root of 3 by that would make it into a perfect square? If I multiply by the square root of 3, do you agree that that's going to make it go away? Why are we allowed to do that? Well, as long as we do the same thing to the top that we do to the bottom, we're really only multiplying by 1. So whatever you multiply by to get rid of the square root, you have to do the same thing to the numerator, and then we're just going to kind of move that square root to the top. So on the top now I have 2 square root of 3, and on the bottom I have the square root of 9, which is... Can I cancel out this 3 with this square root of 3 up there? No, you can never cancel something out inside the square root with something outside of the square root, so please don't make that mistake. It will make me sad. I don't know. It's a surprise. I know. Does that make you sad? It makes you miss all the writing I made you do in pre-calculus? 7 is good. Maybe a little bit of writing in there, a property. Like a property to write down, like this is this.
That's one that we already know, so we don't have to write it.
Sure. This is where you have a problem. You might say, well, let's just multiply the top and the bottom by the square root of 2 like we did over here. But that's not going to work because of this 5 over here, right? If we multiply by the square root of 2, we have to multiply all of it by the square root of 2. So the only way to get rid of this square root in the bottom is to multiply by its conjugate. And so when we have our quiz, there's definitely going to be a question like this, and the directions are just going to say simplify. You got to recognize, oh, I got to move that square root up, and the only way to do that is to multiply by the conjugate. And what would be the conjugate of 5 minus the square root of 2? 5 plus the square root of 2. And whatever you do on the bottom, we have to do the same thing to the top. And it's okay, we like square root to the top. What? You foiled that? Yes. And if there happened to be something up here with addition, you'd have to FOIL the top as well, but this one doesn't have that. What should happen is the bottom should work out to be one nice number with no square root. So if you get a square root in the bottom, then something bad has happened. And on the top, I'm just going to distribute that square root of 3. So let's see if we can agree here. So square root of 3 times 5, 5 square root of 3, and the square root of 3 times the square root of 2. Remember, you can't add square roots, but you can multiply them. You just multiply and keep it under a radical. So that's just going to be the square root of 6. On the bottom, for me, I know the conjugate, the middle part always cancels out, so I don't always write that. I will on this one for you. But if you recognize that the middle is going to cancel out, you can just do the outside and the inside. But this would be 25 plus 5 square root of 2 minus 5 square root of 2, and then minus the square root of 4, which should always be a perfect square when you end up with that. And so again, it's kind of up to you on how much work you show on the bottom part there. But that middle part crosses out. And for me, I know that the square root of 4 is just 2. So I think we should end up with 23 in our denominator. Do you agree with that? I can't do anything else with that. Like, that's just my answer. If the bottom number was something that was divisible by all the numbers in the top, then you could simplify it if you wanted to. Well, you should simplify it. But this one does not simplify, so I'm going to leave it like that. Questions about that? We did that last year a lot as well. The only other thing in 5.8 is dealing with rational exponents. And remember that any root can be written as a fractional exponent. And so I just want to remind you of those as well. Rational exponents. For any real number b, and any positive integer n, remember that if you have the nth root of b, that's the same as saying b to the 1 over n. This? That's just nothing. something there. I think it's just a comma. Like there was more stuff after it, and then I didn't. I copy and pasted this. And so any root that you write, you could also write as an exponential, a fractional exponent. Your calculator can do fractional exponents too, as long as you put the whole thing in the exponent. But 27 to the 1/3, the bottom number is your root, right? So this is the same as saying the cube root of 27. And the cube root of 27 is And so last year in Algebra 2, we spent a whole day. I know I didn't spend it with you, but I used to teach Algebra 2, so I like to say that we did this. But last year in Algebra 2, you spent a whole day just practicing writing from fractions to the radical form and going back and forth and working with ones that worked out really nice. We're just going to kind of skip ahead to the fact that we can go one step further with this, and we can put a number other than 1 up here. And so that's my next thing I want to do, maybe. Sometimes I forget what I've done. Okay, so we can also say that for any non-zero number b and any numbers x and y, we could give you a fraction here besides just like 1/3 or 1/2 or 1/4. And we can write it 2 ways. Again, you need to remember that the bottom of that fraction is your root. So like 1/3 is a cube root, 1/2 is a square root. So the bottom number is your root, and the top number is just like the power, like if you were going to square something or cube something. So the top number is your power, the bottom number is your root. So you can either write it like this, or I think this is a better choice when we're simplifying this without a calculator. You can take the root of it, and then you can take the power on the outside. I know questions like this you can do on your calculator. If it's a decimal, you might have a little bit of trouble with your calculator, but some calculators even do these nicely. There's a few of these on your homework, and what I want you to do is, I'm fine with you checking it on your calculator. I want you to show me that you can rewrite this and that you could do this without a calculator. So I need more than just an answer on these when you're doing these. So 27 to the 2/3 power, what I want us to do is rewrite it. And remember that the bottom number is the root. So I could say that is the same as the cube root of 27. And then I can put the power on the outside. I could have also put the power with the 27, but without a calculator, I don't know what 27 squared is. So that's why I put the power on the outside. Because I do know what's the cube root of 27. 3. And then I have the power on the outside, and what's 3 squared? 9. So I want to see some work with those. I want to know that you're not just typing in your calculator, because I'm not really checking that you know how to use your calculator. What if I gave you this one with a negative exponent? 16 to the negative 3/2. What do we do with negative exponents? Move it to the bottom, yeah, so I can do it the same way as I did the other one. The first thing I could do is I could move this to the bottom and make it positive, so it's going to be a fraction. This is where maybe if you type this in your calculator, it might give you a decimal as opposed to a fractional answer, and that's how I would know you did do it using the property. And then how could I rewrite this? What number is my root out here going to be? Yeah, it's going to be the square root. So I'm not actually going to put the 2 out there, because square root I don't have to put out there. And then 16 and the 3 is the power out here. And again, I always put the power on the outside because I don't know what 16 to the 3rd is. But I do know what is the square root of 16. 4. And then 4 to the 3rd, maybe you don't know, but 4 times 4 is 16. And then times 4 again is going to be 1/16. 4. So I definitely want fractions as opposed to decimals, which means I want you to actually think it through a little bit. Think about that. So we can also throw in variables with fractional exponents, and it goes back to what we did on day 1. You have to know your rules of exponents. When you add exponents, when you multiply exponents, when you subtract exponents. and then you're dealing with fractions on top of that. So that's my last two examples. We'll hide this scary one. And you're just going to simplify, and so it goes back to making sure you know exponents. What do we do when we have a power to a power? What do we have to do with that? So we have to multiply those exponents, right? And we have to make sure we give that exponent on the outside to everything on the inside, even if it was a number. But we're going to multiply. What is 3 times 1/3? Just 1, so I'm not going to put the 1 on there. And what is 6 times 1/3? 6/3, which is just 3. Okay, so, no fractions left. I think most of these work out pretty nice today. But you got to remember that you're multiplying there. So now I can take it and we can do something that looks like this. How about this problem? That looks a little scary, right? I'll give you a minute to write it down. It's just like what we did on day 1, only now it's fractions. Outside. An idea though. Exciting. That's what I was about to say. It's how I spend my Saturday nights. Doing problems like this. Put the kids to bed and break out the math book. I don't even need to go to the store. I just got the book on the shelf. Just like before, you have to kind of work this through in steps. If you had a negative exponent, the first thing I would do is be moving it around. When you have something with a parenthesis and an exponent, you should be giving that number to all those exponents in there and multiplying it. So a little bit of work to do here, but I'm just going to multiply. And remember, when you multiply fractions, you just multiply top times top, bottom times bottom if nothing cancels. So x squared to the 1/3 is just going to be x to the 2/3. Agree with me on that? And that's just going to be y to the 1/3. And then I have to give this 2/3 to both of these. So right now is x to the 1st. So 1 times 2/3 would be x to the 2/3. Y to the 4/3. 2 times 2/3 is just 4/3. And on the bottom, I just have x to the 2/3, y to the 2/3. And from here, you have choices, just like we did on day 1. You could, on top, could we combine the x's and add those exponents together, and combine the y's and add those exponents? Totally the right thing to do. Some of you might notice that you could cancel out an x to the 2/3 with an x to the 2/3 down here. That's okay to do too. It doesn't matter in what order we do this. I'm going to just combine my top first, but I just wanted you to know that if you canceled this out, you're still going to get the same answer. But what do we do if we have x to the 2/3 and x to the 2/3? What do I do with those exponents? I add, and how nice those have a common denominator already. What is 2/3 plus 2/3? 4/3. And the good news is you have a calculator. You can add it on there if you didn't know that. What is y to the 1/3 times y to the 4/3? 1/3 plus 4/3 is 5/3. Everybody with me on where I'm getting that? So it would be 2x to the 2/4. No, because you're multiplying, and when you multiply, you just add the exponents. Just like if we had x times x, it's just x squared, it's not 2x squared. So we're just adding the exponents. Now what do we do here when we have division? We can subtract the exponents. And again, very nicely, they're common denominators. We can just say, what is 4/3 minus 2/3 is x to the 2/3. And what is 5/3 minus 2/3? 3/3, which is really just 1. Oh, I don't even need to put the 1 there. I almost put a 1. Right? 3/3 is just 1. So that big ugly mess simplifies down to x to the 2/3 y. Questions on that? This is the end of our little section here before we're going to have a quiz. So tomorrow we'll kind of review what we've done. I'll give you a review worksheet, and that'll be like kind of your study guide for the quiz that we'll have on Tuesday. Nathan, do you have a question? Like the cube root of x, like that. If you wanted to, you could. Since they gave it to you in fractional exponents, I'm fine with leaving it like this. If you wrote it as the cube root of x squared, and then I'd probably put the y in front of that, because that way you know that's not under there. You could do that. It's the same answer, but I would just probably leave it as a fractional exponent. It's not wrong if you did that. Alright, so here's your homework. It's not that many problems here. 78, 79. It's kind of jumping around here, but 45, 48, 50. And then those are the conjugate stuff. And then 56, 63, and 65. Those are the ones that you can use your calculator to help you, but show me some work on those. And then 68 through 72 even are like the ones with the x's and y's. Again, not that bad to do. Remember that all of your homework is due on the day that we have a quiz. That would be next Tuesday. All the homework from R7 and R8 is due. So if you've been slacking off and not doing it all and just writing the problems down, make sure you go back and do that, because that's going to be a good amount of points on the day of the quiz.